Hello, my name is Alex, and my project for ME499 is to design a powered air filtration and dehumidification assembly for 3D printer enclosures, the goal of which is to improve overall safety and reliability of operation within your workspace.
This product will be comprised of the sheet metal frame holding all of the components, including a small blower, a power source, a 3M particulate air filter, some color indicating desiccant beads, and fasteners. The product works by pulling air through the 3M filter, removing off-gassed particulates from printing filament, then passing this through the desiccant beads which pull moisture out of the air. The desiccant beads change color from orange to green as they become saturated, indicating they should be changed. The sheet metal frame is the primary product that I designed and manufactured during this process, and each of its 5 components experienced cutting, forming, and finishing operations. These parts included a top plate, bottom plate, 2 desiccant baskets, and a desiccant bracket holder. Here's the whole frame. These components were designed and manufactured by me using Cox Racing Group's machinery in Newburgh. All of the components were laser cut out of 1/16 aluminum due to its affordability, durability, and corrosion resistance. Then they were given a consistent finish by removing their scale with a surface grinder called a time saver. Following this, the components were deburred on a grinder and belt sander as needed to ensure their overall safety of handling. Finally, those components that needed to be bent to shape were: the desiccant baskets were formed using a manual bender, creating approximate 90-degree angles as they were relatively simple and dimensionally non-critical. The bottom plate and desiccant bracket holders were formed by me using a press brake. Here's my dad running prototypes for demonstration as I forgot my tripod. Several issues arose during manufacturing that should be discussed. Primarily, the lack of included bend indicators on my products made replicating the parts on a press brake hard and multiple attempts necessary. In addition, the bottom bracket had to be redesigned due to it being impossible to manufacture given our tooling, and the proximity of the bends highlighting the need to converse with manufacturing before designing a product, a key component of this class. A second iteration of products were created with slots instead of holes to allow for easier assembly, even with dimensional inaccuracies occurring due to my lack of experience with a press brake. Lastly, there are several holes and a large flat plate on my housing that did not end up getting used or implemented yet. These will house servos to actuate vents to control airflow and an Arduino to orchestrate them. However, I fried my current Arduino and the replacement has not arrived yet.
While this component is affordable and has an attractive aesthetic finish, it can be better made as multiple components by a 3D printing enthusiast. I plan to upload all files to Thingiverse so that others can improve the safety and reliability of their 3D printer while operating within their home.